In this video, I'm going to talk you through Pythagorean triples. Now, you're most likely familiar with the Pythagorean theorem, where a squared plus b squared equals c squared. This is only true in right triangles, but what's neat is Pythagoras, once upon a time, he and the Pythagoreans were like obsessed with whole numbers. So here are the four smallest whole number side lengths that make a right triangle, aka that satisfy the Pythagorean theorem. So that means that 3 squared plus 4 squared is 5 squared. 5 squared plus 12 squared is 13 squared. 8 squared plus 15 squared is 17 squared. And 7 squared plus 24 squared makes 25 squared. So you actually have to have these memorized. Okay? The way I think about it, I just rehearse this in my head and I write it down. I do this repeatedly. I'm like 3, 4, 5. You got to have that one memorized. It shows up a lot. 5, 12, 13, 8, 15, 17, and 7, 24, 25. So you notice sort of the 5 at the end of one of them kind of brings you to the next one. Also, the 17 kind of leads into the 7. So keep in mind the largest side needs to be the hypotenuse. And so these are time savers. And I'm going to show you how you could save a day of your life over the course of it if you do enough mathematics. So you don't have to use the Pythagorean theorem. You can just be like, well, I trust my dude. I trust my dude Pythagoras here. And, well, rather than doing 30 squared plus x squared equals 50 squared, well, you instead could just say, well, I know, my spider sense goes off. I know that this is kind of like a 3, 4, 5 right triangle. Now, you could say, well, this is kind of like a 3, 4, 5 right triangle. The 30 goes with the 3, the 50 goes with the 5. It's like we took our 3, 4, 5 right triangle and we scaled it up. We multiplied it by 10. So our last side, we'll just scale it up by 10 as well. The 4 will now get scaled by 10. This last side is 40. That's by triples. 3 squared plus 4 squared makes 5 squared, just like scale everything by 10. 30 squared plus 40 squared is 50 squared. So the missing side is 40. And you didn't have to square big numbers and no giant square roots. It's just a quick time saver. Now, if you want, I'll draw this right triangle as well. But really, behind the scenes, you're asking yourself, what is the greatest common factor between 12 and 20? What's the biggest number that goes into 12 and 20? And that's 4. 4 times 3, and then we have 4 times 5. Okay, well, that's interesting. It seems like both sides are scaled by 4. What's the leftover? Oh, there could be a 3 here and a 5 here. 3 scaled up by 4 makes 12. 5 scaled up by 4 makes 20. So this is, again, our favorite one, 3, 4, 5. And we're scaling up by 4. So 4 times 4. X is simply 16. I just used some similarity. I did not have to do the Pythagorean theorem, and that's kind of sweet. Pythagorean theorem is great. It's always in your back pocket, but it kind of takes some time. So now we're given two numbers. We're going to ask ourselves, can we break this down? Well, what's the greatest common factor of 14 and 50? What's the biggest number that goes into both of those? Well, that would be 2. We have sides of, it's like we have 2 times 7 and we have 2 times 25. So now your spider sense should go off. Both of these sides are multiples of 2. So if we divide by 2, we look at the leftover, it's like we have a 7 and a 25. And then you have your triples memorized. You have 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25. So the larger leg is 24. And then we can just scale it up. Times by 2 to get that side, times by 2 to get that side, times by 2 to get the missing side. 2 times 24 is 48. That's what x is, and no squaring necessary. So we're using similarity, we're using similar triangles, we're breaking down what we're given, and we're sort of mapping it to a triple and then scaling it back up. So again, we're given two sides, we want to find the missing. The greatest common factor of 15 and 39, well, that's interesting. They're both multiples of 3. We have 3 times 5 and 3 times 13. That's really what we're finding the greatest common factor of. So the biggest number that goes into both of them is 3. So essentially, if we divide by 3, we have a 13 on our hypotenuse. We have a 5 here, and this last side, triples, 3, 4, 5, 5, 12, 13. And then we'll just be sure to scale it up by 3, because every side was multiplied up by 3. So x will be 12 times 3. That's 3 dozen. That's 36. So triples are time savers. You don't have to square. You're just using research that other people have done and the concept of similarity to save yourself oodles of time. All right. Let's see. Okay, here we go, another one. Oh, so this is 8, 15, 17. But wait a moment. Recall, the hypotenuse needs to be the largest side. This would have had to have been 17, and this would have had to have been 15. The legs need to be shorter than the hypotenuse. So if they were 8 and 15, then the hypotenuse would be 17. But that's not what we're given here. We're given that x is the hypotenuse, not 17. So this is not a triple. And don't forget what's in your back pocket. Hypotenuse squared equals leg squared plus leg squared. So don't forget, you still sometimes have to do the good old-fashioned Pythagorean theorem. So don't lose that. Not everything is a triple. Sometimes when students learn something, they're like, oh, I'm going to apply everything to that idea. That's not always the case. So just be super careful there. All right? And so then we just put these together. We got 353. We'll square root. We won't consider the negative case because x is a side length. That's a distance. That's a length. That should be positive. So we got 353 here. Okay, and that's probably prime. We should try to simplify this radical if we can, but it feels pretty ugly to me. It feels pretty prime to me. Okay, so we're given two sides in a triangle. We're just going to reduce it. We'll ask ourselves, well, what's the biggest number that goes into 20 and 52? What's the GCF, the greatest common factor? Well, 20 and 52, oh, this makes me think of like playing cards. 4 goes into both of them. That's our greatest common factor. So we can sort of scale this down, divide by 4, this is 5, divide by 4, this is 13. This is truly a 5, 12, 13. Again, you have to have these memorized, though. Scaled up by 4. Scaled up by 4. Do not forget to scale your last side up by 4. X is 4 by 12. That's 48. And that was a nice time saver because these numbers would have been obnoxiously large. Let's do it again. So what's the biggest number that goes into 24 and 51? Well, that's 3 times 8 and 3 times 17. Interesting. That means that our greatest common factor is 3. We could reduce this triangle by 3. The 24 divided by 3 is 8. 17 times 3 was 51, so the 51 divided by 3 is 17. 8, 15, 17. Oh, this one's nice. We've got our hypotenuse is 17, so this all holds up. That's great. We scale up by 3. We scale up by 3. We scale up by 3. And x is 45 without having to do the Pythagorean theorem. So again, let's do one more. Here, our greatest common factor. It's the biggest number that goes into each of these, 40 and 75. 8 times 5 is 40. 15 times 5 is 75. So our greatest common factor is 5. So we can divide by 5. We've got 8. Divide by 5. We've got 15. Oh, this is 8, 15, 17. And then we'll just scale the hypotenuse up. Scale it up by that scale factor. The scale factor was 5. So 17 by 5. X is 85. So this is a tremendous time saver. I don't think we have any more. Let's just rattle these off again. 3, 4, 5. Practice writing these over and over again. 5, 12, 13, 8, 15, 17. Drop off to 10. So 7, 24, 25. And a bonus one, 9, 40, and 41. So here's some triples you should have committed to memory. They will save you time throughout your life. Thanks for watching. Feel free to like or subscribe. Hit me up in the comments. Have a beautiful day.